Welcome back, everybody. Please click on Follow Presenter and let's take a look at the next lesson, additional filtering transformers. There are quite a few filtering transformers. Let's take a look at some of the additional ones. So the tester and the test filter are good for doing complex tests on attributes. There is another one that would work in this situation called the attribute filter. So I'm just going to drop in a test attribute filter here. Now the attribute filter is really handy if you're looking for specific values. So attribute filter, again, I'll call this dog park. We can only filter by a single attribute, so that is a limitation. But then I can enter in the possible values, capital Y, capital N, and I also can simultaneously test to see, is it missing? Is it null? Is there anything else? This can be handy from a quality assurance view. With these transformers, if things don't match, then they just kind of disappear. I mean, the test filter, I could add an additional clause in there for dog park, not dog park, everything else. The attribute filter kind of has that built in. I can also import possible values from either a feature cache or a sample data set. This could be handy if I'm perhaps filtering by zip codes. I could have a data set that contains all the zip codes, and I can import those values. What have we got in advanced? Same thing here. Again, the features come out through the first port that they match. So again, the order of the ports can matter. Although you can't really have a feature that matches multiple ports in this situation. It can't be null and Y. It can't be Y and N. So when I run to this, I get the same sort of result, just done in a different way. I like the attribute filter if I'm trying to do things quickly for specific values. I mean, that's often why I use a tester instead of a test filter. It's slightly faster if I'm creating a workspace where I'm the only person who's going to be using it and I'm only going to be using it for today. I'm not going to be maintaining this years from now. I might prefer testers over test filters. And the attribute filter, if I'm looking for specific values or I want to import those from somewhere, that can be really handy as well. Can you filter the length of values? Not directly within a single transformer, but there is a string length calculator. So with a string length calculator, you can now create an attribute which contains a string length. And then you would filter based on that. So the string length calculator first, and then choose your output. Now, I think string length might also be available as I might be incorrect here. The string length might be available as a function. Let's take a quick look. So I'm going to drop in an attribute manager just to see if string length is available. Input, output, value, string functions. There we are. So the string length is available as a function, which means it actually, you might be able to use that directly. Let's see. So in this, we have a text editor, and we can do String length. There you are. String length of a particular attribute. So yes, you can actually do this directly within a transformer. Then it comes down to kind of personal preference. If you're going to be calculating the string length, hiding that within a transformer might be problematic when it comes to maintenance. I mean, you can do it. Just make sure you've properly added annotation or comments indicating that that is, in fact, what you are doing. So it's very clear to the maintainer of the workspace that I am calculating a new attribute inside of this transformer and then testing based on that. So you can either do it separately as another transformer or in a transformer itself and then go from there. Just use annotation. That actually brings me to the next filtering transformer, which might actually work really well with something like a string length calculator. You might not be looking for discrete values of string length. You're looking at ranges. Now, when it comes to testing for ranges, the tester can do that because you can do a composite test. Same with the test filter. The attribute filter cannot test for ranges. And we also have another transformer that will specifically do ranges, the attribute range filter. So the attribute range filter, if you're looking for string value lengths, we could do a length here, or we could do an area or something like that. Let's see, this only does discrete values. With the test filter and tester, I could calculate, say, area on the fly. With this one here, I'm going to do something like tree count. So the attribute has to already exist. Cannot create the attribute value in the attribute range filter. And this goes from, say, 0 to 100, like small, 100 to 200, medium, and 200 to some maximum value, 1000, and that could be large. Now, those of you who really pay attention to the numbers in these situations may notice there's some ambiguity here. What if something is exactly 100? This works just like the selections in these other ports. A feature goes out through the first port that it matches. If something is exactly 100, the first port that it will match is small. It'll come out through the small port. This also means you could do something like this, 100 and then 90. It'll come out through the small port. There's an overlap here, but features go out through the first port they match. Next up, what if I don't know the minimum and maximums? For something like areas, tree counts, you can't really have a negative. But if you're not sure what the lower limit is, you can just leave it blank. And then it's basically negative infinity. Same with a maximum. I can leave that blank, and then there's no upper limit. Okay, some additional filtering transformers. The geometry filter. We saw this in day 2, filtering different geometry types. The filter that was added in that situation, it was only adding the geometry types that could exist in the source data set. There are additional geometry types that this can support, such as raster, point cloud, voxel, grid, solids, things like that. Hmm. Wonder what detailed is. Handle instances. Interesting. I don't actually know what that means, but not going to look it up right now. Okay, so that is additional filtering transformers. So please review Additional filtering transformers. A couple of questions came in here. Tested the attribute filter on parks and on column neighborhood, getting a funny result as all attributes are sent to the unfiltered port. The attribute filter is case sensitive, so double check that. We'll also come visit your lab in just a moment, see if we can figure out what's going on. If you don't know the ranges, is there something that can create the ranges, like a histogrammer? We did see an example of a histogram with dealing with lists. As for splitting stuff up into ranges, let me just see here. So the attribute range filter, it does have a generate, but that's depending on you filling in the minimum and maximum and then selecting a number of ranges. As for collecting ranges, let's see, statistics calculator. The statistics calculator does have a minimum and a maximum. So you could use that and then run that through an expression evaluator to calculate the ranges at that point. I think that would work. Let's see what else we have here. Value count. There is a range statistic as well um, in the statistics calculator. So I would probably work with a statistics calculator that also has a histogram. So if you're looking to generate the ranges on the fly, I would take a look at the statistics calculator. Okay, so we'll continue at this is a 5-minute one, 9:44, 9:50.